Hi folks, it's Anastasia from Inkwell Games here. We have a new puzzle launch this week, and in honor of that, I'm uploading a series of different solve videos. So I hope these videos help you get started and understand the game and logic of fields. So here's a fields puzzle. In fields, we're trying to fill the entire grid with green and blue cells. These connected cells are called fields. Two fields of the same color can't touch, up, down, left, or right. And the number represents how many cells are in that particular field. I always start off with small regions. And so in particular, I look at this field. This field is going to be one cell. In fact, it already is one cell. So the first thing I do is I mark the cells immediately adjacent to it with a different color, because we can't have a two-cell field if that region is a one. So we know that one is complete. The other thing I like to do is look for cells that are orphaned or need to reach a number cell. So in particular, we have a single blue cell here. It doesn't have a number, so I don't know yet what field it belongs to, but I do know it needs to connect to a field with a number. The only way I can grow this field from one cell to more is to move to the right. So I'm going to make this one blue. That connected it with these. And I know it's going to need to grow more, but right now I don't know if it's going to grow this way or whatnot. So I'm going to do the same thing here. This blue cell is isolated. It's orphaned. It needs to connect to another field. Let's bring it down. It's the only way to grow it. And one thing I realized is if I grew it to the right, it would then connect with this 3. So if I'll just hypothetically put this in for now. But what I realize is this actually makes a field of 4, which we can't have. This is supposed to be a field of 3, which tells me that this cell actually has to be green. I have to separate these two from this 3 because otherwise that field would be too big. In doing that, I actually completed this field. It requires a 2-cell field, and we have 2 green cells here, so let's mark blue around it because we can't have green, otherwise it would be too big. And then I'm going to look up here and realize that, well, if this cell was blue, that would make this field at least 6 cells, which is far bigger than 3. So we're going to green that out to give it some buffer. As I come down, same thing here. If this was blue, the 3 and the 4 would be connected. It'd be connected to this cell. It'd be far more than 3 cells. So this cell is going to be green. I'll do the same here. Again, we don't want to connect the 3 and the 4, and that would make a region that's too big. So that's green. And suddenly this 3 only has one direction to grow to finish its size. So it's going to go here. Now we have 3 blue cells that are connected, the exact right number. This field is complete, so let's green its border out to make sure it doesn't connect with any other blue cells. A lot of different directions we can go from here. I'm going to go over here and see that there's this 2-cell blue region. It needs to grow to connect to a numbered field. Let's grow it down. Now we have 5 cells. This region should be 6. So this is the only way that this field can grow to its complete size. So there we go. That's our 6th blue cell. Now we can block out that border. Now we have sort of 2 orphaned green cells that need to connect to a green number. I'm going to bring them over this direction. Great. Again, don't know which direction the 5 is going to go. Ooh, but indeed I do. If it went up, it would block that 4 and isolate it, and it would be the wrong size for its field. So we know that the 5 actually has to grow right. That 5 is now complete, so these both are blue. Great work. This is an orphan cell. Let's grow it toward a number. This is the only way it can grow. This 4 only has one direction to grow to become a 4-cell field. Now it's complete. Block off the border. Let's see what's left up here. I've got sort of 2 orphan greens here, 5 8s. My hunch is this is going to be green, but let's logic this through. We've got an orphan set of 3. It needs to grow. it can only grow to the right. Again, still can only grow to the right. So now we have 1, 2, 3, 4, 5, 6. That 7 could go to the right or down, but if it went down, it would isolate these two cells and they wouldn't be a part of a field with a number, and it would prevent this from being the full 8 cells. So we then know it actually has to go to the right. And this must be our 8th green cell to connect those with the rest of the field. Let's check it out. Happy solving!